Thanks for coming, everybody. Good to see a steadily increasing showing today. Um, uh, First, I'd just like to say, thanks to Humble for sponsoring and for providing all the pizza and beer. There's plenty more pizza. Feel free to get up and help yourself at any point. And the beer's in the keg at the end. Also, just for your information, the bathrooms out the double doors, the first set of glass double doors to the right. Um, and I also want to mention that we're always looking for speakers. So if anybody has any talk ideas for the coming months, definitely let me know or Trevor, who's co-organizer. And he's actually running a little bit late because of traffic, but he should be here later. And that's about it. I think we have possibly a December kind of combined meetup with the North Austin Golang meetup, kind of in the works, but just a spoiler, I'm not sure if that's exactly happening, but I'm going to talk to Trevor about it later. But anyway, today we have Fuzz testing with Go, presented by Jud White. Really excited to hear more about that, so I'm going to pass it off to Jud. Thank you.
All right, thank you. So, get this mouse out of the way. Let me know if you can't hear me. I'm not known for my loud voice. I don't know if the mic's picking me up. So, does anybody here write unit tests for Go? All right. Does anybody have table tests? Yeah? Okay. All right, so you're already in a good position to do fuzz testing. See if this works. These slides are available online. This bunny here is the American Fuzzy Lop, which is what the package that we're going to be talking about is based off of. It's a package. It's a fuzz tester for C and C++, other binaries. So I'm Jud White. I work at Dell. I work on performance, reliability, backend services. I occasionally contribute to NSQ, which we use in production for over a year now. I like to code. I don't like phone calls in the middle of the night. It's one of the reasons why I like Go. So we're going to talk about what fuzz testing is, why we want to do it, what is a good target for fuzz testing. We'll do a real-world demo. So as part of preparation for this, I looked for a real bug that was out there in the wild, found one, and fixed it, and so we'll go through that. And kind of in the course of that demo and some other talks, we'll discuss like how to do all this and kind of what are the best practices around this. So this is the tool that we're going to be using. It's by Dmitry Bukov. It's called GoFuzz. He's a Google engineer. This is almost like a cheat sheet for you. So if you go get these two packages, you'll get the Fuzz Builder, which will build your package into something that can be fuzz tested. And then you can actually run the fuzz tester on it. And part of that build process is actually rewriting your code for instrumentation. One of the good things about this is that you don't really have to write the test yourself. It's quite simple. You can add a build tag so it doesn't get built with every time you run Go build. You can choose to have it built only for the fuzz tester. It's a simple function. It just takes bytes, returns an int. Your int is kind of like a priority. If you want to increase the priority of a certain input, for example, parser succeeded, you would return 1, otherwise you might return just 0. And you can have different fuzz functions if you want to test different things. And then you just build the package, and then this actually takes sometimes quite a while depending on how many dependencies you have. And then you'll run the fuzz tester and give it a work there with an initial corpus. We'll go over kind of all the details of that. So at any time, we got fairly nice sized crowd, but if you just want to ask questions, just shout them out. So what's fuzz testing? Why do we want to do it? Well, even when we're really careful, everybody makes mistakes. It's unavoidable. So every time I write something, I get an index out of range if I try to do even the simplest kind of parsing. Some nice examples of stuff that we probably all ran into before. Do we remember to sanitize the input? Do we handle UTF-8 correctly? And it seems funny, but you can imagine this actually happening in real life. Put something in there, you just crash the whole system. And this is the wrong time to ask if you remember to clear that buffer. So if anyone's watching Westworld, maybe you get this joke, if maybe not. All right, so what are we trying to accomplish? We want to find inputs which cause our program to misbehave. So that might be a crash, or it might hang, might consume large amounts of memory, it might just do the wrong thing. How it does this is it does coverage guided testing. So as it's running these different test cases, it actually will measure, did I hit this line of code, did I hit this line of code? If I hit something which I haven't seen before, if I've reached a branch which I haven't come across before, that's interesting. We'll add that to the corpus. And it works very much the same way as the test package if you do a cover profile. And then as it finds new interesting inputs, it mutates them. It may do a bit flip. It may copy part of it to another part. There's a couple different things. Next slide, we'll talk more about that. And you can find bugs with this that are really difficult to find just by straight unit testing. Some things, just if you think you got all the edge cases, sometimes you just don't. And a good target for this is anything that parses any kind of text or any kind of binary into like structured data. And you may not do that, but maybe your dependencies do. And maybe your dependencies aren't all that well tested. That's actually kind of the example that I'm going to show, even though this one was well tested. So we talked about all this. These are the kind of issues that we can find. And here's kind of how it works. So you start with this left-hand side of this corpus, which is like an initial body of tests that you want to run. And you can actually generate this. This is why I asked about if anybody's doing table tests. It's because you can actually generate an initial corpus, which gets you good code coverage, helps speed up the fuzzer, helps it know how to hit different lines of code. And it takes this corpus, both your input and what it's found on its own, and it does a couple different things. It might mutate it, which would just be like flipping bits, or copying pieces around, or just trying something kind of random. And there's also a thing called a versifier, which actually tries to figure out the structural layout of text protocols. So for example, you might, if you pass it in XML or JSON, you may see things repeated within your serialized data. So that's how the versifier works. And it picks one of those paths kind of randomly, and then I'll execute it. If it crashes, that's a crasher, and we'll get output for that. If we have new coverage, we go up, it'll try to minimize it. So, you don't want to look at some long string of bytes and try to figure out, okay, how did this cause my problem? It'll try to minimize that code to give you the least amount of bytes possible to crash your program. And the sonar step is actually, as it's instrumenting your code, it's looking for comparisons so they can make more intelligent decisions about what kind of input to feed. So it's not just completely random. There's a couple of pretty well tested and interesting steps that it takes to try to get the best data to crash. So what kind of things do we want to fuzz test? Parsers. If you're reading anything off the network, especially if it's untrusted, or even if it is, it's a real good candidate. Any kind of compression, serialization, any kind of language, if you're doing parsing of like some context-free grammar or something, those are all really good areas to look at. And then also if you're refactoring, you can take some old implementation that was maybe slow but did the job, and you run it through bench and you see that it has 1,000 Alex per op or something, and you want to try to minimize that. And you write something that, okay, now I've got 0 or 1 Alex, whatever. It's much faster, but are the results really the same? And even if we have an extensive test suite that we could feed to both implementations, we may not catch everything. We may just want to understand how they're different. Maybe we don't care that they are different in certain cases. So anyway, you can use fuzz testing to do that too. So here's a simple program. One thing to note is that you cannot fuzz test package main, which means that if you have an executable and you've put all of your logic into there, you'll have to separate that out into a package that can be imported. So just keep that in mind. So we have some function. This source is actually in the repo where the talk slides are, so if you want to play with this. And here we're looking for a very, very specific 8-byte character string. So it's 8 bad food. That's what we're looking for. And if we get that, we want to crash. And our fuzz tester just calls our test with whatever data it decides. And if we get an error, we'll panic. If not, we'll just return 0. And you build the package, which creates a zip file, which will contain your instrumented code. And then you run it, and it actually catches that case in about 3 seconds on my laptop, which to me is pretty impressive. So this is the output. So the corpus is just how many different inputs it considers interesting, how many crashers it's found. The rest of it, the coverage is sort of like the number of bits in a hash of the input that's going in. If the cover number goes up, it's not directly related to lines, but you do want that number to go up. It means that more of your code is being instrumented. A couple other options. So I talked about having different fuzz functions. So you could have, one that just, if you just do something really simple, but maybe you want one that says, okay, I want to just beat on one particular part that takes in the stream of bytes. Then I also want another one that compares, the old slow versus the new fast. And as I refactor the new one, I still want to make sure that they're good. So you have 2 different functions, and as you build it, you can specify which function you want to actually have fuzz tested. So remember, we got that crashers 1. So we have this work there, and actually, let me show you that. I think that'll be a good example. So this is my work directory. This is my initial corpus. It's a SHA-1 hash, and then I believe the number after this is the priority that was assigned to it based on how many lines of code it hit, and so on. And then in here, actually I don't have any crashers, but let me do a quick demo. Yeah. All right, so copy paste. All right. Well, that's what you get when you do live demos. I didn't get a crasher, but I do have the output. Okay. So you have these folders, your corpus, your crashers, your suppression. So the interesting one for us is going to be the crashers folder, what crashed. You can look at the raw bytes that were sent. So you can see that string of bytes matches the input that we were looking for where we did a panic. The output is actually stack trace of wherever we were when we hit a panic. And then the coded version is actually a version that you can copy and paste, put into your test. So that you can, now you found something that crashes your program. Okay, well, we want to add a unit test for that so it doesn't happen again. So look at a real world bug. So quick background. We recently deployed our first customer-facing Go service. We were super excited about that. We did not expect for it to take 1,000 times the traffic that we were planning for. Luckily, everything's okay, we think. So We are using loggers, we have structured logs, so we want to start looking at time taken, HTTP status codes, and so on. And we want to especially do this as Black Friday and Christmas are coming up, because who knows what that number is going to jump to. So we have kind of two packages out there that can read log format. The one that I originally used was KR log format. That guy, I believe his name is Keith, he's still active, but he's not really maintaining that package. The other one is sort of taken over by Chris Hines, who's active on Slack anyway. I believe he's part of GoKit as well. So he's working on that one, so I looked into that. I was excited because he actually has fuzz tests. So I was like, well, this is going to make a terrible target for a demo. You know, somebody who kind of knows what they're doing has already done the fuzz test, so all right, well, I'll take a look at it anyway. So we all make mistakes, right? So he's testing a pack-unpack sequence where he's fed in some data, he tries to deserialize it, and then reserialize it, and then come back out and make sure that the results are the same. And what he was actually doing, and we worked on this, fixing this issue together, is that he basically took the raw data twice and made sure that the results were the same. So that happens. So like I said, it was well tested. It had like 80% coverage, so I had a good place to start. So I used the existing test cases to generate a corpus, and this is his actual code. I kind of snipped it a little bit, but so he has a table test in here. And then he was ranging over it, and then the part that I added was just to write out the bytes into the directory. So this function here is something that you could copy and just put into your tests and generate this corpus. So does that make sense what's going on here? Is it we have some bytes or maybe a string that we cast to a byte slice, and then we just write it out to a file so that fuzz tester can start with that. So we build it and run it, and we crash. So we have some kind of problem. But it wasn't a panic. So panics are really easy because you get whole stack trace, you get line numbers, you can easily pinpoint, okay, I got index out of range over here, or I had a nil dereference over here. But this was a logic bug. So it was a little bit more difficult to kind of track down, especially with a code base that you're not familiar with. So what I did was I took that quoted output, created a single test for it, and then just ran coverage on it. I started looking for anything that was highlighted in green to focus my attention on, and kind of figure out, okay, that's what's interesting, and then I need to figure out, okay, so what's broken? Encoding, decoding, possibly both, not sure. And don't worry about the text on here if you can't read it, but this is sort of a comparison of, so on the left-hand side we have what the unit test covered, and then on the right-hand side we had what the fuzz tester covered. So you can actually tell the fuzz tester to dump out a cover profile so you can see what it's hitting. That's interesting for a number of things. One is, well, you know, you can show that, hey, my unit test coverage, maybe I could take some of those things that it generated and use them as tests, or maybe something similar that at least lights up the same lines. But if you find red where the fuzz tester is, either you need to give it some kind of input to help it along, or you may have dead code, right? You may have a condition that just never gets hit. You could simplify a little bit. So root cause on this one was UTF-8. So it wasn't the most interesting bug, but it was kind of challenging to kind of figure out exactly what was going on. So basically, if you had a bad rune come in, it would get encoded as the literal bad rune character, and then the literal bad rune character be encoded as the escaped bad rune, which is the /u FFFD. And I did want to show the pull request. Chris was really nice and worked on this with me. So I showed him, so I added some tests for him. I showed him, hey, this is where these new tests, which now pass with the change where they were failing with the previous version. And I called out that so correctness came at a cost. Is that the benchmark here was not good here. Wasn't sure if it was really worth it, and but I thought that there were probably some things that we could do to improve the performance. So Chris gave me feedback, and we worked it out, and we got much closer to where we were. So anyway, it was just nice working with somebody like that. So yeah, best practices. Create an initial corpus out of your tests. And just like a unit test, you want to, you commit your unit test to source control. You probably want to do the same thing with your fuzz functions and even your corpus, because somebody else that pulls down your code from GitHub, or even if you use Git internally and they want to run fuzz testing, you kind of want them to start at the same place where you are. Anything that you find that crashes, that's of course something that you want to add to your tests. Watch your benchmarks, because a lot of times when you make these kind of changes, you might have to do extra checks. Like in that one, I was doing UTF-8 valid string, and actually the way we worked around that is that we just looked for if it was less than rune self, then we wouldn't bother with checking that. So we gained a lot of performance on that. And this wasn't our code, but this was something that we were relying on. So today, actually, we got an email from the people that collect money, and they said, the holidays are upon us, make sure you monitor everything. And then the next email in my inbox was from the Splunk admin saying, please don't kill Splunk. So we want to feed this data into Splunk, but because it sort of makes sense to have that common platform, but at the same time we don't, because we don't, if Splunk goes down and we can't monitor, then we're in trouble. So we kind of pick our own destiny on this. So we parse our logs ourselves and create our reports ourselves and alert ourselves, even though we have Splunk in place. And there's other things too, like if you're parsing HTTP headers, you have some funky input or something. This past week, I found 3 bugs in the .NET framework related to parsing HTTP headers. Not Go related, but it can happen. And the person who wrote this actually found over 100 bugs in the standard library. A lot of them are fixed now. So if you want to play around, I don't know if the first 3 have bugs, but they definitely look interesting. So a supposed reflection-free zero allocation JSON encoder, that gets my interest. Comcast MPEG streaming, that definitely gets my interest. The New York Times one, that was actually an example. That was an example I was going to show, but the other one actually turned out to be a little bit more interesting. And what I was going to show there was their version used a lot of like string index, string split, blah blah blah, a lot of allocations. Took a while to do. I rewrote it. I had index out of range, blah blah. But there might still be something there. And then if you want something that for sure has a bug, Damian Grisky shared with me this intentionally buggy package, which is just sort of like a way to test if you want to just mess around with something. So Filippo Valsorda from Cloudflare, he has a really good talk and actually a really good article as well about how they found problems in their DNS parser. It was actually interesting because we don't normally think about security bugs in Go, but when you're parsing records which contain pointers to previous data and things aren't quite right, you can have maybe a leak in other people's data, or if you're not zeroing a buffer or something like that, all those different pieces. So Damian Grisky also has a GoFuzz tutorial. American Fuzzy Lap is what all this is based off of. There's derivatives of this for Rust, for Python, OCaml, .NET has something called IntelliTrace. It's on like its 4th incarnation. It used to be called Code Digger, Smart Unit Tests, PEX, and it's only available in VS Enterprise 2015. So Dmitry Byukov did a GopherCon talk at 2015. He's the author of GoFuzz. He also has slides up, and then Filippo Valsalva also did one at GothicGo. Damien Guski shared with me a ton of links on other things that I do not understand yet. A lot has to do with more on simplifying crashers and also parsing structured text. Maybe I put this in for me to check out later, but I also think that if you're interested in this kind of thing, that it might be for you. And then also there's something which I wasn't aware of until recently. There's a testing quick package in the standard library, which kind of goes hand in hand with this GoFuzz, which is a different package. And I believe they're kind of meant for like testing serialization, deserialization, and getting like concrete types back instead of just byte streams. So special thanks to Dmitry Byukov for GoFuzz. He also wrote the race detector. He also merged my fix for making this work on Windows. Damien Grisky gave me feedback and lots of resources. Chris Hines for the GoLog format thing. And Florin Patsan gave me feedback, and will eventually reinstate Party Parrot on Slack, I promised. I have a couple other talks, if you're interested in that. They're on the slides. That's it. That was a lot quicker than I expected. Sorry. Any questions? Yeah. I can just repeat the question if you want.
Thank you. My question is, can you see the random data generator?
Can you see the random data which is generated?
So like RNGs, like random number generators or data generators, often will take a seed so that your inputs are predictably random. Does GoFuzz provide the ability to do that, to specify that?
Not that I'm aware of, no. Okay, so the question was, can you seed the randomness?
Right. Yeah. So if you did find a case for which you didn't have coverage and you wanted to hit that code path again, you would just have to run the test again and hope that you hit it.
Oh.
Or is there something built in that allows you to do that?
Yes. So great question. So the question was, if I hit it once, how am I going to see it again? So in my code example, which was write corpus, I'm using SHA-1, but honestly, the first time I did it, I did CRC32. So you can see this is what I generated from the tests. Then all of these here were actually placed here by Fuzz tester, which is quite a bit more. So you won't actually need to run it. You won't have to run it again and wait for it to hit it. As soon as it lights up a new code path, it's going to get added to the corpus. Anything else? All right. Well, thank you all.
So thanks, Jud, for coming out, and this was a really fun talk. I wanted somebody to explain this to me a little bit more since I saw Dimitri's talk back in 2015 at GopherCon. I guess right now we're kind of just in lightning talk mode. If anybody's got anything fun and interesting you want to share, for now until pretty close to 9 probably, since on the scheduled time. And at some point tonight, I want to talk about whether and where and what we will do in December, since this seems to be as good a group as any to decide whether we want to have some kind of social meetup or an actual meetup or nothing at all.
Yeah, my company's looking for Go developers. If anyone's looking for a job, we're a small 4 or 5 people company, just got acquired by a giant company, so think like less stock options and more like really good benefits, but also a really fun company. We're called Meshify. our IoT company. We're doing smart sensors and platform technologies to do analytics on real-world industrial sensors. And we got bought by an insurance company, so we're doing. They do equipment insurance, so we're monitoring buildings, equipment, schools. I think they're covering 200,000 or 300,000 schools that we're looking at doing